So hello there. So this video is all about interrupts of the STM32 Nucleo board, specifically the external interrupt and the timer interrupts. So first, let's first demonstrate the external interrupt. So launch your STM32 Cube MX, then hit New Project. So now. You might be using a different STM32 chipset. So in my case, I'm using the STM32 F446RE. So yeah, you could choose that one. So you might use the board selection, but I prefer the MCU selection so that I can really configure the pins and all. So go ahead and search your STM32 chipset. I just bookmarked my chipset and click on Start Project. Now, again, we'll be working on first with the external interrupt, mainly external interrupt input. So, I would be demonstrating is using the user push button of my development board. You know this colored blue button, so that is the user button. So that would we will configure it that it would act as the external interrupt input. So first, you should have your a schematic design copy of your Nucleo board. I have one right here. Then you could just search and look for the user button, and where was it? Yeah, it's this one, B1, and it is connected to the PC13 of our MCU, STM32 MCU. So let's go ahead and search there, PC13, and let's configure it as a GPIO external interrupt. So click on that one, and also just for the sake of demonstration, upon clicking the push button, the user push button, it will load an interrupt event, and that interrupt event should toggle an LED of our development board. So upon clicking the button, it would generate an interrupt, and it would toggle the state of the LED. And yeah, that's basically how we demonstrate the external interrupt right now. So now let's look on where our built-in LED is connected to. Where was that? Yeah, here. The LED was here in the extension. Yeah, here. It is connected to PA5 of our MCU. So yeah, T13 right here. So PA5, let's configure it as a GPIO output. So now we have set our push button as an external interrupt configuration, and the LED as an GPIO output. But now first things first, we need to enable and configure our external interrupt. So go on with the system core and click GPIO. So again, we will configure our interrupt pin, PC13, and once you click it, it will show this panel right here. And there's a lot of selection for the mode. There's the rising edge trigger detection, the falling edge trigger detection, as well as the rising or falling edge trigger detection. So let's head on back again with the schematic. As you can see, this is the user button, my user button, and it is pulled up. So its default state, it is high. So we want that whenever we push the button, it would light or toggle the LED. So in that case, from high, and upon clicking it, it will go on to the ground, short to ground. So we would have a falling edge detection. So let's choose on that one. I mean, it's up to you. You could also choose the rising edge trigger detection. Basically, this would trigger the interrupt once you release the push button upon clicking it. Okay, so and the rising and falling edge trigger detection, it would generate two interrupts upon clicking and also upon releasing the push button. So you can choose which mode you want. I would just choose with the falling edge detection, and that's it for the GPIO. But of course, we need to enable our external interrupt line. So click on enable from our NVIC or vector interrupt controller. So yeah, I guess you are done. Yeah, first things again, before we head on, we need to configure the clock configuration. So I set my clock configuration to 16 megahertz simply because I want the clock tick to occur per 1 millisecond. So there's a calculation that on your datasheet. You can find it on your specific model and go to the timer. But yeah, you can go ahead and explore on that one. Basically, in this demonstration, I'll be using the 16 megahertz and a prescaler of 15,999 prescaler, so that we could generate a 1000 hertz clock frequency. In that way, we could have a clock tick of 1 millisecond. So I've also choose the HSI or high speed internal clock. So yeah, upon configuring that one, go on to the project manager, name it whatever you want. Demo external interrupt. So I'm also using the MDK ARM chain toolchain, the Kale ID. You could also choose the STM32 ID if you're using it. So another one is to copy only the necessary library files, because we don't need to import all the libraries. So yeah, you're done. So let's generate the code for configuration. So STM32 makes us coding much easier with this STM32 Cube MX, because it does like the pin configuration in a UI setting, which makes us, I guess, developers easy to start the code. So click on open project. So now let's head on to the application user, then click on main. So this is the main file right here. So everything is pretty much done by the STM32 Cube MX, because yeah, it has already configured the pin for us. So what we need to do is just go onto the interrupt event right here, interrupt event handler here. So again, we want our LED, built LED, to toggle its state whenever the interrupt or the external interrupt happens, basically when we push the push button. So what we want to do is GPIO, and click on toggle, enter toggle. Then again, our LED was located in the port A, pin 5. So enter the port right here, then GPIO pin 5 there. So yeah, that's pretty much it. And click save. So basically what we are doing is just to toggle the pin 5, and whenever the interrupt occurs. So I hope you already know the concept of interrupts. It's basically allowing your main program to do freely what it's doing until such cases where uh, let's say in our mode, a falling edge trigger is detected in our interrupt pin. It will momentarily pause the program and head on to this interrupt handler, execute its code, then it will go back to where it is left off in the main program. So yeah, let's build the project by clicking F7. So now you have to make sure that you have connected your Nucleo board to your computer to load the program. So you can check here at the target options, go on to debug and settings. And as you can see, my Nucleo board is connected to the computer. So, okay. So now yeah, let's load the program. That's done. Let's go ahead and check on our Nucleo board. Now we have our program flashed into our board. Let's click the reset button first, and now we should expect that if we push this user button here, we should light up the LED, and if we click again, it will turn off. Basically, it will toggle the LED. So let's click that one first. There, the LED lights up, and if we click again, it will turn off. Again, turn on, turn off. So this is the external interrupt at works. So basically, it will interrupt the main while loop that you have in your main program, and it will momentarily stop and execute the interrupt handler and go back to the main program. So the concept of external interrupt is quite important if you have like a sensor or a sensor that needs to be handled first before you continue the main firmware program. So now that we are done with the external interrupt, let's move on with the timer interrupt. So go back again to your STM32 Cube MX, then hit the new project. So again, select your STM32 chipset. Mine is the STM32F446RE. Click start the project. So here, basically there are a lot of timers in our STM32. So you could go ahead and datasheet. There's tons of I think there are 15 timers, but each one of them has their own specific capability. So since this is just like a timer, a basic interrupt timer, just go use the basic timers right here, timer 6 and timer 7. So this is basically how the basic timer works. You have here the trigger controller. So whenever this will basically handle the interrupt clock, then it will, let's say the 16 megahertz that you have fed up upon here, then it will scale down that 16 megahertz clock cycle depending on your pre-scaler in such a way that it would count the counter, and you have also a predefined value right here that if it matches the counter, it would trigger the interrupt. So go ahead and explore that in your datasheet. So actually what we are just doing right here in the timer is we want the LED to blink every 1 second. So again, as demonstrated in the external interrupt, our LED is found at the port A, pin 5. So we just need to set that as GPIO output. Then next thing is go on to the timers. So again, we'll just choose either timer 6 or timer 7. I'll just choose the timer 6 and click activate it. And our prescaler is again 15,099. Basically, it yeah, there's the calculation there in the datasheet. I won't explore on that one too much. And here is the loaded 65535. It's basically the max counter period, because again the timer 6 is a 16-bit timer register. So but we just need the timer interrupt to happen every 1 second. So since we have configured our prescaler in such a way that it would tick in 1 millisecond, so 1000 millisecond, which is equals to 1 second, is our counter period. So after that one, we need to again enable the timer 6 global interrupt. Then yeah, you're pretty much done. Click generate code. Before, again, let's check with our timer. Again, I'm using the 16 megahertz clock, and the project manager, I'll just name it demo timer interrupt, and choose MDK ARM. Then copy all the necessary library files, then click generate code. Then click open project. Now let's go on to the application user. First, go to the main file. There are a couple of things that we need to add. First, we know that the STM32 Cube MX basically handle all the pin configuration, but we need to set the start of the timer clock interrupt. So again, our interrupt handler is found here at the STM32F4XX underscore IT. So here this is the timer interrupt handler. So again, same thing with the external interrupt. We want to toggle the LED. So let's enter that one, GPIO toggle, then GPIO A, GPIO pin, was it 05 or 5? Forgot, it was 5, I guess. Yeah. So, but again, we need to set things first in the main. We want to start the timer interrupt before loading, before it goes to the while loop. So now, before we flash the program to our board, we need to call this variable right here. Basically, this is the timer handle type variable that has been called also here at our interrupt handler. We want to call its address and basically start the timer interrupt. So let's go on inside the main function. Let's enter hardware abstract layer, then TIM for timer. We want the base to start, but we want to start the interrupt. So we just pass on the address of this variable right here. So for the address, use the ampersand HTIM 6. Yep. So yeah, you're basically done, and we have set our interrupt handler to toggle the LED every time the interrupt is called. I mean, every time the interrupt is triggered. So again, you could add some code right here, everything that you want, without worrying the timer program, because again, it is handled in the interrupt handler, and it will just basically be called whenever the interrupt happens, and it will just resume your program. That is the beauty of interrupt. And so yeah, let's first build that one. 7. So the build has done. Now we will load the flash the memory. Again, make sure that your board is connected to the computer, so click download. So yeah, now let's head on to our board. We are back with our board. We have flashed the program. Once again, click the reset button. So there, upon reset, it will load the program, and every 1 second it will light the LED, turn off the LED, toggle the state, and that's how the timer interrupt works. So you could have the main program running on your main file while not worrying the timer delay. Again, with the delay, I discourage using that, because again, it takes a lot more resource than just using the interrupt. You're basically using the polling method on that one, which is which could slow down your your program, and it's not ideal for like a big scale project. So interrupt is much more efficient, and good. The nice thing with this STM32, there's a lot of timers, and this could use a lot of timer interrupts. That's it for the timer interrupt. So that's it for GPIO external interrupt and for the timer interrupt. And I hope you have learned something. And yeah, see you in the next video. And in my next video, I'm planning on making a video about the compare mode of the STM32, both the output and input. So the compare function is quite useful to like determine the period of a signal, and also generating like delays. It is sort of works like a timer interrupt. So see you in the next video.